All right, so for example number 2, we're going to do more of the same. Here's the thing. Remember these patterns of transformations, right? So now we're going to transform the absolute value function. So we know that when I draw an absolute value function, the parent function, and you'll hear Mr. Adams use that term a lot, parent function just means the basic form of the function. So the parent function in most cases is the easiest or simplest one. So if I say f of x is equal to the absolute value of x, that's an x, that looks like this. It's symmetric about the y-axis. But you can transform it, right? You can move it, just like we did all the other functions. So remember that a does what? It stretches vertically, or it compresses vertically, or it flips if it's negative. B compresses horizontally, or it stretches horizontally. H shifts it up, or it shifts it down. And K translates, shift is one word, but really the formal word is translate. Shifts it to the right or left. And remember that H, because the formula is a negative, it goes in the opposite direction. Okay? So for example number 1, they say, hey, find the vertex. Oh, lastly, when they say the vertex is this bad boy right here. Remember that the vertex is just H, comma, K, always. So we're going to do a bunch of things, quadratics, absolute value functions. There's some other functions too, like cubics and stuff. But this HKAB thing is how we transform all functions. They have them set up in a way that it does all this moving left to right, stretches it vertically, compresses, stretches horizontally, whatnot. You could flip it upside down if A is negative. So right now, the first step in this process is really to identify what's going on. So I know that A is equal to 4. I know that H, because the formula has the negative sign in there, is actually equal to positive 5. I know that the K, because the formula has a positive for K, is actually equal to negative 2. If H is positive 5, that means we go 5 units to the right. If K is negative 2, that means we go down 2 units. I know that the vertex of this bad boy is 5, comma, negative 2. And A, because it's a greater than 1, it's going to stretch it by a factor of 4. And it's not negative, so it's not going to flip it. By the way, look at where my vertex is. Does that look skinnier? Does that look like you took the graph and stretched it? Okay, so they're going to say a bunch of words here. But basically what they're saying is, what do you notice? What's the difference? So to kind of illustrate this, what I want to do is let's plug in our calculators. Let's go to our calculators. And right now we have the absolute value of x, correct? And so what I want to do is I want to show you guys something. So the first thing I want to do is I'm going to graph 4 times the absolute value of x. So remember, to get the absolute value brackets, you hit math, go to the cursor one time, and choose or select ABS, which will pull up your absolute value brackets. And I'm just going to put x. Let's graph that real quick and take a look. So what the 4 does is that stretches it vertically. Do you guys see that? Okay, thank you. I know you guys are thinking it. Yes, Mr. Adams. And then I was like receiving it. But the verbal confirmation is helpful. Some of you were thinking other things. What am I going to have for lunch? I wonder what they're serving. Bosco sticks? No, that's never done on Wednesdays. Yeah, I'm recording it. Oh, people love it when I make fun of students. So let's move on to the next one. So now on the next one, we know that that stretches it vertically. Let's do this. Let's do the absolute value of, now this time I'm going to put in my x minus 5. Now what you'll see when you graph that is it just moves it over 5 units to the right. Do you guys see that? Mm-hmm. Yeah, sorry. This right here. And Mr. Adams is changing it to, you don't have to do this, but I'm going to show you the different steps to get the final. So you should get something like that. All right. All right. Now let's do for another equation the whole thing again, but we're going to say 4 times the absolute value of x minus 5, and then move over outside the parentheses, and what was it, negative 2? So that purple function is the final function, right? So what did I do? I went from the red line, and then I manipulated it by changing a, and that what that did is it stretched it vertically. Then I shifted it over 5 units by saying x minus 5 inside the brackets. That moved it 5 units to the right. And then when I put the negative 2 outside of the brackets, that dropped it down 2. So let me take a little screenshot so you can see the transformations. So that's how we got this stuff. Okay. And I mean, that's basically what all these words say. All right. So let's do B and try to do this from scratch. All right. So for B, we're going to say that A is equal to 1. Doesn't really impact anything. B is equal to, I'm going to say negative 2. We'll talk about that in a second. H is equal to negative 3 because it's the opposite. In order for me to have a positive 3, I have to have a negative 3, right? And then K is just equal to 1. So that means that my vertex should occur at H comma K or negative 3 comma 1. So if I go over negative 3 comma 1, I should have a vertex right here. Okay. So it says the vertex of the parent absolute value function is 0, 0. G of x is a translation of f of x. How many units to the blank and how many units to... So we know, what does h do? It's 3 units to the left. And then K does 1 unit. Notice that they have plural units and unit. 1 unit. What does positive 1 do? Moves it up 1. So what they're saying is, hey, if your vertex is here and you go 1, 2, 3, and down 1. Oh, wait, it's up 1. Guys, pay attention. I graphed that wrong. I put negative 1. 3 comma 1 is up here. I did that to see if you were paying attention. Good job. All right, cool. So the vertex of this bad boy should be negative 3 comma 1. Now determine where the points. Now what they're saying is, look, there are points on the original graph. But really what I'm going to do is I'm just going to graph it, right? So it says determine where these points would be. So what I would do is I would shift things over manually, but I'm just going to graph it, right? So since b is equal to 2, right? Well, they're saying that it's a negative. They're saying that b is equal to positive. Oh, the absolute value of b is 2. So let's finish this before we graph it. It says since the absolute value of b is 2, what does that tell you? Well, what did the b thing do? Well, it's a horizontal stretch, right? So if b was a fraction from 0 to 1, that would be compression. But since I got to spell horizontal right. So this is a horizontal stretch, right? Since it's greater than 1. Does that make sense to you guys? You might not memorize that off the top of your head, but since b is negative, it's a reflection across the y-axis. Is it y or x? It's the y-axis. I don't know if you guys remember that from your transformation section. So let's talk about that. Remember that A is the reflection across the x-axis. B is the reflection across the y-axis, which is interesting because the reflection across the y-axis on an absolute value function doesn't necessarily change a whole lot with regards to the symmetry of the function. So then the x-coordinate will be reflected in the y-axis and stretched by a factor of 2. Because b equals 2. Then moved 3 units to the left, and the y-coordinate will move up 1 unit. So then this is an x value, this is a y value, so this is how you would do this manually. So to get this value, I'm going to say negative 2 times 2, right, minus 3. So this is the b, the x value minus 3. So what we're doing is we're addressing that b is negative and it's a unit of 2. So that's where this comes from. This is from the b term. This is from the h term. And then the y value would just be 2 plus 1, right? So what we're doing is this is an xy value on f of x. And then we're doing the math to the x and doing the math to the y and transforming it. So what's all the math? Well, I know this will be 3. And then negative 2 times 2 is negative 4. Plus negative 3 is negative 7. And then if we do the same thing here, negative 2 times negative 2 is positive 4. Minus 3 is 1. And then 2 plus 1 is 3. Okay. So we just got to plot those 2 points and we have our graph. So we've got to plot negative 7 comma 3 and we've got to plot 1, 3, and that should do it. So I'm going to say 1, 3 over here, and then -7, 3 over here. And that's symmetrical, and that should be the graph. Make bigger dots if it doesn't work. And that's it. That's how you graph it. See how that worked? Any questions on that one? And depending on how much time we have, let's graph that real quick on our graphing calculator and see if those work. So I'm going to go back here and let me clear this, and I'm going to put it in. The function was absolute value of negative. Then I'm going to plug in my 1 over 2. Start parentheses, x, what was it, minus or plus 3. And then what was it, plus 1 on the outside of the absolute value brackets? Yeah. Okay, bye. Plus 1. Let's see if we're right. Yay! See how I did that?
You know how like you're doing the fill out ones? Can you just like print those off?
What do you mean?
Like those ones? Can you just like print those off somehow?